to our next lesson in chapter 7. We're going to talk about congruence. Lucky for you all, everything we're going to talk about in this lesson, we've talked about throughout the course of this school year. Okay, have we talked about congruence? Yes. What is congruence? Yeah, things that are equal to each other or the same. Okay, so we have talked about congruence in the past. Let's say I had triangle ABC, and that is congruent to triangle XYZ. Just from that, do we know which angle is congruent to angle A? Yes. Which angle is equal to A? X. Good. What about angle B? Which one's congruent to B?
Y.
Y. And what's congruent to C?
Z.
Z. Excellent. So the order in how we name our geometric shapes shows you congruency and shows you which angles match up to each other. Okay? What if I said side BC is 4 units? What side in the other triangle would also be 4 units, Sky? YZ. So you not only find out congruency with the angles, you can also find the congruency with all of your sides as well. All right, so we have a little bit of vocab. We just have one word. And our first word is going to be corresponding parts. If we have 2 triangles, and you're going to write this down in your notes, this is triangle ABC, and this is triangle XYZ. What is corresponding to angle A in the other triangle? X. X. Good. They're in the same location. So this angle and this angle are corresponding. Okay. What about angle B? Everybody?
Y.
Good. So B and Y are corresponding. Remember, we use those arches to show congruency as well. Okay. What about angle C?
Z.
Good. Angle C is congruent to angle Z. They're also corresponding. Okay, we also, our only other vocab is our congruence symbol, which we have seen throughout the course of our middle school math experience, but if it doesn't look familiar, copy it down. An equal sign with a little squiggly on top. So our first example, I need you to go ahead and copy those 2 triangles with all of the tick marks and the labels. We need to write congruent statements comparing the corresponding parts in the congruent triangle shown. Okay, so we have to write comparison statements. Okay, so how many pairs of corresponding angles are we going to have? How many pairs?
3.
We're going to have 3 because the triangle has 3 angles. How many pairs of corresponding sides are we going to have?
6.
Pairs.
2.
3. There are 3 sides to a triangle. Okay, so let's first start with our angles. Okay, who can tell me one set of corresponding angles, Haley?
B and R.
Angle B is congruent to angle R. Good job. Who can tell me another one? David? A and Q. Good. Angle A is congruent to angle Q. And Amreen? Angle C is congruent to angle S. Excellent. We need to identify our corresponding sides. So who can tell me a pair of corresponding sides? Sky? Good. AC. And we use this little line on top to say that's the line segment. AC is congruent to QS. Does the order in which I name these matter?
No.
Yes.
Yes.
Oh.
Because I know that angle A and Q are congruent, and I know C and S are congruent. So make sure you are writing them in the correct order. Okay? What's another pair, Amreen?
Angle B and A is congruent to R and Q.
So we said line segment BA is congruent to RQ. Very good. And what is our last one? Isabel?
BC is congruent to RS.
BC is congruent to RS. Very good. In our next example, we have to do the same exact thing, write congruent statements comparing corresponding parts from the congruent triangle shown. Go ahead and copy both of those triangles down, including all of the tick marks that are up here and the arches in each of the angles. Okay, who can give me a pair of corresponding angles? Jaden? Angle Q is congruent to angle B. Good. Hannah?
P and C.
Angle P is congruent to angle C. Good. What do you guys notice about the difference between the last example and these examples?
For the rotation.
It's a reflection. In the last one, they were oriented the same exact way. It's not always going to be that simple. Sometimes they might be reflected or rotated. So you really have to think before you write, because they're not always going to look like they're in the same spot. Okay? All right, what's our last corresponding angles? Irene? Angle R is congruent to angle D. Very good. All right, let's do the sides now. Someone from the door side. Somebody tell me a pair of corresponding sides. Line segment QR is congruent to segment BD. So you can tell me another one. Jordan?
What it, P and R and, B and C.
PR, not DC. It's going to be, because these are corresponding. So it'd be CD. Does that make sense?
Yes.
Good. And the last one, Sky?
BC.
BC is congruent to QP. Very good. Turn to page 523 and do letter A. All right, final example that we're going to do today. It says triangle ABC is congruent to triangle XYZ. Write congruent statements comparing the corresponding parts, then determine which transformations map triangle ABC onto triangle XYZ. So we're going to be doing today's lesson, but then we're adding on yesterday's lesson from 7.1, figuring out which transformations will give us the end result. Okay, so I could go through this coordinate plane. I could count how many jumps for each side line. I could use the distance formula for my diagonal lines to find the length of each side to see which ones are congruent. I can do all of that. Or I can do it the easy way. Do you guys know how to do it the easy way? Nope. We talked about it in the beginning of the block. Yes, you did. We have triangle ABC is congruent to triangle XYZ. So somebody tell me a pair of angles that are congruent. I'm reading.
A and X.
Good. A and X are congruent. Good. Haley, give me another pair.
B and Y.
B and Y are congruent. Josh. C and Z are congruent. The order in how shapes are named shows which angles are congruent to each other. Very good. Okay. Now what about the sides? Somebody give me a pair of congruent sides. Ezo?
AB and XY.
AB is congruent to XY. Excellent. Hannah?
BC is congruent to Y and Z.
Good. BC is congruent to YZ. And our last one, Tatiana? Good. AC is congruent to XZ. And they are all located right there as well. Okay, are we done with this problem?
No.
No, the last thing this asks for, we need to identify which transformations were done to ABC to get XYZ. Is there one or two transformations? There are two transformations. What's the first one? Good. First thing they did was reflect it over the y-axis so that we had something like that. So we first reflected over the y-axis. Then what did we do? Amarine? We translated it 2 units down. Very good.